7.1, nth roots and rational exponents. This is the second day. Before we start, I'm using my airliner versus the smartboard today. So every time I pick a different tool, you're going to hear a little tap like that. So sorry about that. Just kind of ignore it for now. So what are we doing today? We're doing exactly what we did yesterday. We're talking about fourth roots, doing exponential rational exponents. Rational exponents means I have a fraction in my exponents, or I'm doing an nth root, like the fifth root or something. And the difference today is now we're doing this with equations. I'm talking about solving equations here. And in solving my equations, what you want to do first is the thing that's being raised to the power, this x to the fourth, this entire x minus 2 to the third, I want to get that by itself on one side of the equal sign, just like if it was an x squared or an x, and then solve for it. So in this letter A, for example, my first example, the PDF is online. I can, the first thing I would do is I would divide by 2 to both sides. So then on my left side, I get x to the fourth. On my right side, I get 81. At this point, what do? Well, I want to get x to the fourth by itself, so I need to take some sort of root. I'm going to take the fourth root. What I do to one side, I need to do to the other. So I'm going to take the fourth root of 81. Well, the fourth root of x to the fourth is just x. The fourth root of 81, well, I'm going to go to my course pack, page 706. Pause this and get that out if you need to. Okay, so I go to course pack, page 706, and I look for the fourth root of 81. Hey, 3 to the fourth is 81. I need to try to memorize these, and so, but right now, use the course pack page if you need to. 3 to the fourth is 81, so that means when I take the fourth root of 81, I'm going to end up with 3. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. But you always have to remember, this is a fourth root. A fourth root works just like a square root. And that's not a 2. I want a 3 there. So a fourth root works just like a cube root, a square root. And not only does 3 times 3 times 3 times 3 equal 81, positive 3, but negative 3 times negative 3 times negative 3 times negative 3 is 81. I'm still not getting the look I want. So I can have positive or negative 3 as my answer. Both of these will work in my original equation to give me 162. So my final answer is x equals positive or negative 3. So let's look at letter B. In letter B, I have x minus 2 quantity cubed. If I really wanted to, I could multiply all this out, come up with an x cubed degree 3. Yeah, I don't want to solve it that way. What I want to solve it this way instead is, since the cube is by itself, I just want to get that taken care of. So I'm going to do the cube root of both sides. When I do the cube root of both sides, on my left side, I'm going to come up with x minus 2. On my right side, I'm going to have the cube root of 10. Now, if I look on that page 706, there is no number that multiplied by itself 3 times. No whole number that multiplied by itself 3 times is 10. So I'm not going to have a nice 3 or positive negative 3. The one thing that you need to talk about right now, though, is this cube root of 10. I want to leave as cube root of 10 for now. Realize there's no plus or minus in front of it. It's just the cube root of 10. Because if I take the cube root of a number, of a negative number, it's going to be negative. A cube root of a positive number is going to be positive. So there's no positive or negative on this. At this point, I'm going to get x by itself by adding 2 to both sides. So I get x is equal to the cube root of 10 plus 2. I could write that as 2 plus the cube root of 10. Either way, I'm going to come up with the same answer. That is my exact answer. If I want an exact answer, that's it, the cube root of 10 plus 2. But what if I don't want an exact answer? I want a better understanding of what that means, so I'm going to find an approximate answer. So to do this, I'm going to pull out my handy-dandy little calculator. I'm going to do my cube root. Now, there's two different ways of doing the cube root. If you look on your calculator under the math button, item number 4 is a cube root, and item number 5 is an x root. So if I ever have to take a fourth root, a fifth root, or a 10th root, let's say I needed to take the fifth root of a number. Let's say what I would do is I would clear out of this. I would hit 5. The fifth root would be number 5. So this is the fifth root of, and let's say I said that 32 would give me 2. Yes, I knew that 2 to the fifth is 32. So the fifth root of 32 is 5. Excuse me, is 2. But I'm not doing fifth roots here for this problem. I'm doing the cube root. I could do that use number 5, or I could use number 4. Number 4 is the cube root. So let's take the cube root of 10. I'm going to close my parenthesis. I'm going to add 2. I'm going to hit enter, and I'm going to get approximately 4.15443469. So over here, I'm going to say this is approximately, it says round my answer to 2 decimal places. So the 4 tells me that the 5 stays the same. So it's 4.15. I use approximate instead of equals because this is an approximate answer, not the exact answer. This answer here in green is my exact answer. Okay, so let's do a few more examples and then we'll be done. Example 6, solve the equation, round the answer to 2 decimal places when appropriate. So I want to do the same thing. I want to get the thing to the power by itself. So on letter A, I'm going to divide by 6 to both sides. When I divide by 6, I get x to the fourth is equal to, and by the magic of television, we see that 3,750 divided by 6 is 625. At this point, I want to take the fourth root of this. So I'm going to go ahead and take the fourth root of the x to get x, take the fourth root of 625. So on the left side, I get x. On the right side, since I'm taking the fourth root, I get plus or minus. I'm going to bring up my note sheet, page 706. The fourth root of 625 is 5. So this is plus or minus 5 is my answer. Okay. How about letter B? Well, letter B, again, the thing that's to the third power is by itself. So I'm going to start by taking the third root of both sides, the cube root of both sides. On the left side, I get x minus 4. On the right side, what number times itself is 216? Again, you can look at your note sheet. Cube root, to the sixth cubes, 6 to the third is 216. So when I take the cube root of 216, I get 6. Remember, there's no plus or minus. It's just 6 whenever it's an odd power. So I then add 4 to both sides, and I get x to be 10. The only number that will make this statement true is 10, while on letter A, plus 5 or negative 5 would make this answer true. Last thing is letter C. Well, last problem on this page, x minus 4 to the fourth power is equal to 625. So again, the thing that's to the fourth power is by itself. I'm going to take the fourth root of the left side and the fourth root of the right side. Just like right above on letter A, the fourth root of 625 is 5. So on the left, I get x minus 4 is equal to, and here I get plus or minus 5. I'm going to go ahead and I'm going to add 4 to both sides to get x by itself. And I'm going to get x to be 4 plus or minus 5. I cannot leave it that way. I have to say that x is equal to 4 plus 5, which is 9. And I need to say that x is equal to 4 minus 5, which is negative 1. So my final answer is x is equal to 9 or negative 1. I need to actually see those two answers. Okay? So those are those problems. That's what we're working on. I've got one more example, and I'll be right back. So if you look back at the notes that we've done, example 5 was solving. I could use either the if it's a perfect fourth, a perfect cube, I can solve it out, or I can use my calculator to find approximate. I then said, okay, well, let's look at some more of these, and I had to remember if I can come up with an exact answer, I want the two exact answers, or if it's one exact answer, I want that, but I need to have those answers. Well, what else can I do when it comes to solving a problem? Well, the last thing that I can do is, oops, do not look behind the fuzzy wall, is an example like this. A basketball has a volume of 434 cubic inches. Find the radius of the basketball to the nearest tenth of an inch. Well, as I just covered, the volume of a sphere, a basketball is a sphere, is 4/3 pi r cubed. I want to find the radius of this sphere, so I want to say that my volume, I know that my volume is 4/3 pi r cubed. But I also know that my volume is 434 cubic inches. So I want to find my radius as best as I can. So the first thing I want to do is I want to get my r cubed, the thing that's being cubed, by itself. The r is being cubed, so let's get that by itself. The first thing that I want to do is I'm going to clean this up just a little bit. And I'm going to get rid of this 4/3 by, since it's 4/3, I multiply by its reciprocal, 3/4. What I do to one side, I do to the other, multiply by 3/4. I'm going to think of this as over 1 so that I can reduce or do whatever I need to do there. On my left side, my 4's cancel, my 3's cancel. So I'm left with pi r cubed. On my right side, if I take this, I'm going to go to my handy dandy little calculator since I have it. I'm going to clear off what I've done before. 434 times 3 divided by 4, which is 3/4. I get 325.5. So over here I have 325.5. Now I want to get r cubed by itself, so I'm going to divide both sides by pi. And I get r cubed is equal to, well, what are we going to use for pi here? Well, there's lots of different choices. I could use 3.14, or I could go to my calculator. And if I look right here underneath the clear, here is a pi button. I'm going to use that for now. Whenever I have a test or a quiz, if I want you to use a pi, I will say use 3.14 or use the pi button so that you know. So I'm going to take the answer that I have, 325.5, and I'm going to divide it by second caret to get pi. And I get 103.60986 da 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 da. That's what I'm coming up as my answer. Now here I'm going to write 103.61, round to 2 decimal places. But in my calculator, I'm still going to use the entire number. Granted, here I'm approximating. but I'm still going to use as much as the calculator gives me. I'm not going to round as 0.61. Always round at the end. So let's rewrite that. Let's make this look a little nicer. So one more time, here I have, this is my radius cubed is, I'm using an approximation of 103.61. I now want to solve for my radius, so I'm going to cube root both sides. Since I'm cube rooting, there's just going to be one answer, a positive answer. Remember, positive answers are all I can really use anyway, since I want a real world volume. I have a real world volume. I want a real world radius. I could only use real world answer. So my radius is the cube root of 103.61. So I'm going to go back to my calculator, and I'm not going to type in 103.61. I'm going to go to the math button. I want the cube root, so I hit number 4. And I want the cube root of my previous answer, so I don't have any extra round off answer. So previous answer is down here where it says this negative. In blue it says A and S. So I'm going to hit second negative to bring up my previous answer. You can close the parentheses. You don't have to. I hit enter, and my radius is approximately, well, let's go to 2 decimal places. So that says, look at the 6, tells me to round the 9 up. So, I don't want equals. I want to say that this is approximately 4.70 inches. Just like I cube rooted my number, I can cube root my inches cubed, and I get inches. So my radius is 4.70, 4.7 inches. That's the radius of my basketball. So the radius of my basketball. So I can then say that my answer is the radius of my basketball, don't make fun of my typing, is 4.7 inches. And I'm going to slide over here, and I'm going to say is about 4.7 inches. I give you a question in words. I would like your answer in words. So please don't forget that. The radius of my basketball is about 4.7 inches. That's what we're doing when we're solving equations. I can always go to a word problem. Hey guys, have a great day.